Let's take a look at this screenshot that was uploaded by this person. And I know that I've got some other videos, some other submissions that I haven't made videos for, but it's so quick and easy to do a response like this to the screenshot that I just wanted to get it out. And I do think there's some interesting analysis to do here, just in the sense of helping people understand how to interpret these traces and interpret what's going on. So what is going on? We're doing a roll. I believe the gyro is, let's see, the gyro is positive, the RC command is positive. I believe that's a left roll. RC command goes positive, gyro goes positive. While the gyro trace is climbing, that means the copter is accelerating into the roll. While the gyro trace is flat, that means the copter is continuing to move at the same rate, neither accelerating nor decelerating. While the gyro trace drops, the copter is decelerating. And when the gyro trace hits the zero axis, the copter is stationary. And when the gyro trace goes below the axis, now the copter is moving the other direction. Okay, so we've slowed down, stopped, and then bounced back the other direction. This is very common to see at the end of a flip or a roll because we're not flying a simulator. So if we think about what happens as the stick returns to center, the P term begins slowing the copter down. And at the moment that the stick hits center, the copter is supposed to stop. But the P term, if we're doing a left roll, we've been pushing to the right to slow the copter down. And if the stick movement is very abrupt, as it usually is, the P term will usually overshoot and have to and rebound because it will be working so hard to slow the copter down that it'll push too much in the other direction and rebound. And that's what we see here. And that's almost always going to be the case. Even in a case where you look at the video and it looks like it's a perfect flip or roll, usually if you look at the traces, you will see the tiniest bit of rebound. It's just so small you don't notice it in the video, small and fast. So if we look at what the P term is doing here and the I term, we can sort of analyze why this is happening. And specifically at this moment in time, right here, this is where RC command has begun to drop, and P, you'll notice P goes negative. So P positive, because the gyro is positive and RC command is positive, positive P means we are pushing into the turn and trying to go faster, and negative P means we are pushing away from the turn and trying to go slower. Okay, so as RC command starts to drop, P goes negative right here and is slowing it down. But notice that at this moment, P goes positive. P realizes that we have reached zero angular rate. You see, right here, and right here, and right here. The stick is centered, the gyro is reporting zero angular rate, and P says, okay, we did our job. And P goes to zero, meaning that when P is zero, that means that the copter should keep doing what it's doing. So if it's standing still, it needs to keep standing still. If it's spinning to the left, 360 degrees per second, it needs to keep doing that. Whatever it's doing is the right thing for it to be doing based on the stick position. Okay, so in this case, the stick position is centered, which is commanding zero angular rate. We've achieved zero angular rate, so P jumps up to zero, saying, keep doing what you're doing. But of course the copter has momentum, it can't stop on a dime. So the P term has been pushing to the right, trying to stop the turn. At the moment that the P term goes to zero, the copter now has some momentum the other direction. The motors don't spin down instantly. The motors are still pushing that direction, and the copter begins to rebound. Okay? Now that's just normal P term operation. That's how it works. That'll always be true to some extent. If we look at the I term, what we can see is that at this moment where the P term is negative, the I term is also falling. When the P term and the I term are pushing the same direction, what that means is that the P term is not pushing hard enough. It's not able to affect the amount of change desired, and the I term is picking up the slack. When the P term and the I term are opposing each other, so one is negative and one is positive, what that means is that the P term is pushing too hard. And what that usually means is actually there's some external force. So for example, I've noticed that when I do turns, my roll I term pushes out of the turn. It opposes the turn. And I've wondered whether that has to do with the fact that my battery is mounted on top of my copter, and whether as the copter tilts into the turn, it kind of wants to fall over into the turn. I don't even know if like physics if that even makes sense or if that's right or not. And so the I term has to sort of oppose that because the copter is wanting to fall into it. Okay, so if the P term and the I term agree, if they're the same sign, both negative or both positive, that means that the P term is not pushing hard enough. My batteries are charged. and if they have opposite sign, that means that something is causing the copter to go faster, and the I term is trying to rein the P term in. Okay, so fine. In this case, we see that the I term goes negative as well, and that means that the P term was not slowing the copter down fast enough, and the I term is picking up the slack. Notice then that at the moment that the P term goes positive, the P term has noticed that the copter needs to be stopping. Now it's doing the wrong thing. Go the other direction, but the I term is still negative. Okay? So in this case, we can look at RC command and we can see that the P term is actually correct. The copter achieved the desired angular rate of 0 at the moment that the stick was centered. And the P term is now correctly trying to stop the rebound, but the I term is still pushing to cause the rebound. Negative means right roll, right? We are rebounding to the right. In fact, that's not what we want. We don't want to be moving to the right, this rebound. We want to be stopped. So if we're moving to the right and we want to be stopped, we need to be pushing to the left. That's what the P term is doing. But the I term takes a little while to catch up. So you are correct in that the I term is not helping here. But the solution as how to fix this is not as simple as just saying, oh, you've got too much I. There's an interaction between the P term and the I term. If the P term is doing a good job, I term will be minimized. If the P term is not tuned optimally, I term will have a lot of slack to pick up, right? And it makes sense if you've ever trained the new person on the job site, right? You're doing a lot of their work. You're picking up a lot of their slack. When they get good, you have less slack to pick up, and that's like the P term and the I term. I notice here that at the end of the roll, we have 1, 2, 3 relatively hard, 2 certainly hard, and 1 moderate, and maybe 1, 2 small P term oscillations. And that's obviously, I'm not looking at your video. If I were looking at your video, I might have a different opinion. But just looking at the traces, that seems like more P term oscillation than I would like to see. One way to take care of that is to increase the D gain, although your D gain looks about right. Your D gain, just from what I'm seeing here, looks about right. But one thing you could try is to increase D, which will then sort of tame P a little bit. But the other thing you could try is decrease P a little bit. So if we're in a scenario where P is overtuned, there will be a really hard push this direction, a really hard push that direction, and the copter will be oscillating so much that there will be a lot of error for I to pick up. Is that right, though? Is decreasing P right? The other thing, maybe, no, I don't think so. Sorry, I'm thinking this out. I'm thinking sometimes when you have too much I term, the answer is to decrease P, because if P is making too many oscillations, I term the copter will be constantly overshooting and never exactly right, and therefore I term will have a lot of slack to pick up. But I see here that P term is trying to slow the move down, and I term is agreeing that so P term is not too strong here. If P term were overshooting and overreacting, I term would be opposing it, and it's not. So the fact that P and I here both agree that the copter needs to be slowing down, that means that P is not pushing hard enough and I is having error to pick up. So that means I doubt that there is excess P. Although again, these oscillations here certainly don't make me happy. Yeah, maybe there's too much I. You could be right. The reason I'm hesitant is that it's really unusual to see I responding over such a short time frame. And again, maybe that means you have excess I. I'd really like to know what your I gain is, or your P, your I, and I guess your D as well. I'd be curious to know what it is. I'm really surprised to see I responding so strongly over such a short time frame. Also, these oscillations here in I, those are very suspicious to me. We normally do not see I term oscillating. You see how you can even see it right here. That's very unusual, and you may have excess I. We usually see I sort of going up and down, but we don't usually see it oscillating. And you can see that there's a very strong relationship between the P and the I term. As the P term oscillates, the I term is also oscillating. Yeah, so you may have excess I. If you told me what the numbers were, I could express a more educated. I mean, if you said your I gain was 20, then I'd be like, well, that's clearly not excessive. That's pretty weird. I mean, try it out, see what happens. But if you told me your I term was, 100, well, then I'd be like, yeah, that's probably too high. Okay, so there you go. Hope that's helpful. Happy flying.